Hello students, in this video I will take the remaining properties of square numbers. So let's start. In this we will start with property 6 that states that the sum of first and odd natural numbers can be calculated using n square. How? Let us take an example. Suppose this is a question given to you. Here you can see all the numbers are odd, okay, like 1, 3, 5, 7, 9 and 11. Okay, you have two methods. Either you manually or do calculation like you add 1 plus 3, that is 4, then add 5 to it, you will get 9 and so on. But the another method is based on the property of square numbers. If we use that property, it will be, we will calculate total number of terms present. So as you count here, you will get there are 6 terms. So put this in the formula, that is n square, and when you put the value of n equals to 6, you will get 36. And now confirm your answer with the same manual method as well. You will get the same answer. Okay. So there is one more question. In this, number of terms are 9. So the sum will be n square, that is square of 9, 81. Okay. So here we have property 7, which states that the square of any odd natural number, here the key point is we are talking about the square of odd number, can be expressed as the sum of two consecutive natural numbers. Okay, the consecutive natural numbers can be represented by these two formulas. Okay, by looking at the property you will not understand this. So let us take an example. The question is, express the following as the sum of two consecutive integers. Okay, and the number is 21 square. You have to represent the square of odd number. 21 is an odd number. You have to represent this square in terms of sum of two consecutive numbers. So what are those two consecutive numbers? If we add these two, I will get the square of 21. Okay, so let's start. As we know that for any odd natural number n, we have this property. Now put the value of n here. N is what? 21. So whenever you find n, just replace it by 21. Okay. As you can see here, 21 square minus 1. So what is the value of 21 square? If you remember the table which consists of 30 square numbers, then it will be easier for you. Okay. So 21 square is 441. Put the values over here. Now simplify, what you will get? 440 by 2, 442 by 2. Both the numbers are completely divisible by 2. So ultimately you will get 220 plus 221. When you add these two consecutive numbers, you will get the square of odd number. What is the odd number? 21, and the square is 441. So basically in this question you have to find these two consecutive numbers. 220 and 221 comes after 220. Okay. I hope this thing is clear. Okay. So move to property 8. It states that a triplet of three numbers x, y and z forms a Pythagorean triplet if the three given numbers follow this relation. Okay. The statement is again further it can be explained like, for any natural number m greater than 1, 2m, m square minus 1, m square plus 1 is a Pythagorean triplet. Okay. How? Again a twisted property, but this can be easily explained with an example. Suppose the question comes like this, and this property is very important, children. Find the Pythagorean triplet whose one number is 12. So basically you have to find remaining two numbers which will form a Pythagorean triplet. Okay, so how we will start the solution? As we know that if three numbers are in Pythagorean triplet, they should follow this sequence. Clear? So if we take any one of three, like if I start with m square minus 1 equals to 12, because these three terms represent three triplets, three terms of a Pythagorean triplet. So if I start, say I assume m square minus 1 is my triplet 12. Okay, one of the triplet of 12. So I equate it. So m square I will get 1 minus 1 will be transposed. I will get 13. And you know that 13 is not a perfect square. So the value of m will not be an integer. So this case will not solve my purpose. Again, let us assume I will take m square plus 1 equals to 12. Okay. Again m square you will get 11 because plus 1 will be transposed and you will get 11. M is again not an integer. Okay. So this case is also not for me. So which one is remaining now? 2m. So equate 2m equals to 12. So m equals to, I will get 12 by 2, that is 6, and it is an integer. Okay. So here I have got the value of m. Why I did these three steps? To get the value of m. Okay. Now I have to form the three triplets. So Pythagorean triplets are 2m equals to 2 into 6. Now I have got the value of m. So just put the value of m in all the three terms. First triplet is 12, m square minus 1, second is 35, and the third one is 37. So 12, 35 and 37 make a Pythagorean triplet. Okay. So these type of questions will be asked to you in the examination. Okay. So here let's move to the last property of square numbers. This property says the difference between squares of two consecutive natural numbers is equal to the sum of natural numbers. Again, you cannot understand by just reading the property. So let's quickly move to the explanation. Basically, the explanation of the previous statement is this. If we are given two consecutive squares and we want to find the difference of those consecutive squares, so the difference can easily be calculated by this property. Just put m plus n. How? Suppose question is you have to find a difference between 45 square minus 44 square. Okay. So first method, you will find the square of 45, then you will find the square of 44, and then you will find the difference between the two squares. Time consuming process. So if you get a question like this, okay, just replace it. M equals to 45 and n is 44. Okay, so just replace m plus n by 45 plus 44. So 89 is the difference between the squares of two consecutive numbers. Clear? Such a simple thing. Again, one more example. 105 square minus 104 square. So children, think if you don't use the property, the sum is going to be a time consuming. Okay. Now m is 105 and n is 104. Just put here and the difference you will get 209. Clear? So students, basically there are 9 properties for square numbers. I have explained each and every property. Now it's up to you how you practice them. Okay. Thank you.